In this video, we're going to talk about arithmetic sequences. An arithmetic sequence is a sequence of numbers whose difference between numbers is constant. So in this first example, we need to determine if the sequence is arithmetic. So in A, it says 2, 4, 8, and 16. Well, the difference between 2 and 4 is 2, and then 4 and 8 is 4, and 8 is 16 is 8. So this is not an arithmetic sequence. On B, we have 6 to 12, which is a difference of 6, 12 to 18, which is 6, 18 to 24 is 6. So yes, that is an arithmetic sequence. When you write an arithmetic sequence, you have two types of formulas or equations, which are recursive and explicit. In a recursive formula, you always have to give a starting value, so A1, and then the formula that you follow is A sub n equals A sub n minus 1 plus D. So I'm going to give you an example based off of B that we did previously. The first term in part B above is 6, so A sub 1 is 6. That's where I'm starting. And then to write the formula part to help me get the other numbers, you write A sub n equals A sub n minus 1 plus D, which is the difference, and the difference on part B was 6. So if we break down that formula, that A sub n minus 1 means the previous term. So if I want the third number, I have to look at the second number and then add 6 to it to get it. So if I want the second number, I have to look at the first number and then I would add 6 to get it, which is why I always need to know a starting value. I need to know where I'm starting because I have to use that number to get to the next number. The next formula, explicit, is much simpler because it's explicit. It tells you exactly what you're looking for by just plugging in one thing. So if I wrote that formula, it would be A sub n equals A1, which is 6 in this case, plus n minus 1 times my difference, which is 6. If you want, you can leave it like that, or you can distribute this 6 through, and then you will get A sub n equals 6 plus 6n minus 6, and then simplify that, and you just get 6n. Either way is fine with me. But what type of function does the explicit formula look like? So if we look at this here, or even this one here, this is a linear function. If you graphed that function, like you plugged in 1 and then got the y value, plugged in 2, got the y value, so on and so forth, you would see that it graphs a linear function because it has a constant change, which would be a slope in this case, or a rate of change for a linear function. The variables, A sub n is the term number you want. This is the desired term number. N is the number of terms you have in your sequence. A sub 1 is your first term or your starting term. It may not always be the first one, and I will give you an example of that in a minute. And then D is difference. Alright, so in our next examples, we have to find the 10th term. So in this first one, first thing you want to do is find the difference, because I'm going to use my explicit or my recursive formula, whichever one I want, but in order to do that, I always need to know the difference. So the difference between all of these terms is negative 10. Right, plus or minus is very important in this case because I need to know if I'm subtracting or adding to get to the next term. Now, I could use a recursive, but if I have to get the 10th term with a recursive formula, that means I need to know the 9th term, which means I need to know the 8th term, the 7th, so on and so forth. So an explicit is probably going to be easier in this case. So to do that, I write A sub 10. Remember, A sub n is the term I want, and that's 10 in this case. I want the 10th term. Equals the one I started with, 13.1, plus n minus 1. N is 10 in this case, because that's how many terms I'm looking for, times my difference, which is negative 10. And then you just solve that. So if I solve all that through, you find out that the 10th term is negative 76.9. All right, next example. This one, it has a little bit more work to it because you'll notice we start with the third term and they give me the sixth term. So what I like to do is use my explicit formula, which is that a sub n equals a1 plus n minus 1 times d up here that I've highlighted. Remember, I told you a sub 1 is really just your starting term. Because what I can do here is I can start wherever I want. So I could say that's my a sub 3, 4, 5. This is going to be the sixth term, which is the 16,384. Or if I wanted, I could re-index this and say, okay, I'm going to say that's my first term, which makes this 2, 3, which makes this my fourth term here. And then with that, I can plug it in the formula and find different pieces that I'm looking for. So what I'm going to do first is plug in the fourth term here, which is 16,384, equals what I started with, which is 64 in this case, plus, now what would n be? Well, again, I'm starting at a1, I'm going to 4, so that's 4 numbers, minus 1 times d. That's what I need to find. I need to know what the difference is so that I can get to my 10th term. So if I distribute this, or simplify this first actually, don't need to distribute, I'll just simplify it. 64 plus 3d. And if you solve that, d ends up being 5,440. So the difference between all these numbers is 5,440. So now I need to figure out, okay, how am I going to get to the 10th term? Well, in the original sequence, before I re-indexed it, the sixth term was 16,384. So if I want, I could just keep adding a bunch of numbers, figure it out. Or I could plug it in the formula again. Well, if we go back to the formula, I need to know what a sub 1 is in the original. So in this original where a3 is 64 and a6 is 16,384, I need to figure out what would a sub 1 of that original sequence be. Again, I could just subtract 5440 from each one. So I could start at this 64 and subtract 5440 and then subtract another 5440. If you do that, you get negative 10,816. That is the way that I would suggest you solve that problem. If you like the formula, you could do it that way as well. And so I will do that right now for those of you who like using formulas. If I want a sub 1, I know that the third term is 64. So again, I'm referencing my original sequence here. So my a sub n is 64 here. So 64 equals, and then I need my first term, which is what I'm solving for in this case, plus n minus 1, which would be 3. 3 is your n value here, times my difference, which I found already, which is the 5440. And then I can solve that for a sub 1, and like I said, you get negative 10,816. It's a little more work than if you just started at your a sub 3 and subtracted 5440 a couple of times to get your first term. And then you turn around and plug that again into the equation to get your 10th term that you wanted. So for one last time, I'll write a sub 10 equals my first term, which is a negative 10,816, plus n, which is 10 in this case, minus 1, times we know our difference is 5440. Plug all that in, and you'll get 38,144, which if you just added 5440 a few more times to that 16,384, which was my sixth term, you probably already got there before me anyways. So I am not picky about how you find these different terms. At some point, you will have to use the formula to get something, and then if you just want to use basic addition or subtraction to go from there, that is perfectly fine with me. All right, last two, we're going to find the missing terms. So in this first example, we have 84 as our first term, and then we're looking for the second, and then we need the third. So what I can do is plug it into the formula that I know. I have 110 equals a sub 1, which is 84, plus n, which is 3 in this case because I have 3 terms, minus 1 times my difference. Solve all that, you get a difference of 13. And then I can say, okay, well, that means 84 plus 13 would give me my second term, which is 97. So your second term is 97. Not so bad when there's only one missing term. For part B, we have quite a few missing terms. But again, if you just label them like I did in part A there, it gets a little easier because you can just use the formula from there. So I know a sub 1 is negative 10, which means this is 2, 3, 4, 5, 6, 7. All right, so I have 26, which is my last term, equals my first term, which is a negative 10, plus I have 7 as my n value, minus 1 times d. So I need to figure out what the difference would be between all these terms. So I used the information they gave me, which was a sub 7, the desired term I had. Use my first term, n is 7 because I have 7 numbers, and now I can solve for d. D ends up being 6. Then, like I said, you don't need to plug in the formula and say, okay, well, now my desired term is a sub 2, and then I have to plug it back in to equal my first term plus n minus 1 times d. There's no reason to do that over and over and over again. That's just silly. So if I know my difference is 6, just go ahead and add 6 every time. So negative 10 plus 6 is going to be negative 4, then 2, 8, 14, 20, and then ends with 26, which would be a way to check your work. Okay, plug in, find all the missing things, plug numbers back in. Do you end up where you're supposed to end up for that specific term number? One thing I want to point out before I finish this video is this piece right here, the 7 minus 1 times d. If I simplified that before I solved this, I would have 26 equals negative 10 plus 6d. So what does that 6d mean? Well, if you look at our sequence here, starting at negative 10, I have 1, 2, 3, 4, 5, 6 differences to get to the 7th term. So I'll let that sink in. If you have any questions, let me know.